Assalamualaikum and hello. In this video, we are going to learn about mechanism of free radical substitution reaction. Let's go to the introduction of this mechanism first. Free radical substitution reaction is a mono substitution reaction. Mono means one. So, it is a reaction condition where there is only one hydrogen atom from alkane is replaced by one halogen atom from halogen molecule. We know that in alkane, there is only carbon and hydrogen atoms. So, when alkane undergo free radical substitution, it can form a single product only. There are a few examples of alkane that can you use. Usually we can use the most simplest one, which is methane. Next one we got ethane. Methane is CH4, and then ethane is CH3, and then we got cycloalkanes. It can be any form of cyclic alkanes but without branches. So we can choose the first one, cyclopentane, it is acceptable, or cyclobutane or cyclopropane. It depends on the question. And last one is neopentane. So this is how neopentane looks like. You got one carbon in the middle bonded with 4 methyl groups around it. So this is 2,2-dimethyl propane, the IUPAC name for this structure. But another common name that we can use is neopentane. So please remember, when we do the free radical substitution, it means that we need to substitute something with something else. So in this case, halogen atom will replace or will substitute with the most stable hydrogen atom. I highlight the word stable here so that you can know that it is very important for you to understand this part. So what does it mean by the most stable hydrogen atom? I hope you can get back to the subtopic where you have to determine the class of carbon and hydrogen atom. So in terms of stability of hydrogen atom, the least stable starts from primary hydrogen, followed by secondary hydrogen, and the most stable is tertiary hydrogen. For example, you got a molecule with many different classes of hydrogen atoms. If the question asks you to show the mechanism for free radical substitution, you can only show the mechanism for the most stable hydrogen atom, which means that you need to show only for the major product. The rest of it you can only show as the minor product. But when showing the mechanism, please remember, choose the most stable hydrogen atom in your alkane. So I hope you all can still remember how to give the class of hydrogen, which depending on class of carbon atom. Next one, I'm going to use example 7 to show you how to illustrate the mechanism of free radical substitution reaction. First thing first, read the question carefully. This question asks you to describe the mechanism of methane. So please remember, please highlight here, you got methane with chemical formula CH4 with bromine. So you got bromine here. So it means that you are going to react methane with bromine molecule, Br2, in the presence of inert solvent with sunlight. So when you do the free radical substitution, usually you will use one extra inert solvent, dichloromethane, with a compulsory condition under sunlight. I hope you still remember about organic solvent dichloromethane that I taught you in the previous video. So how to start for this kind of question? First thing first, you have to do the chemical equation. So for your reactant side, you got CH4, your methane, reacts with bromine. So you got Br2, and then to produce if the solvent is given in your question, you have to put in your equation. So how? You put on the top of the arrow, which means here. So I'm going to put CH2Cl2 on the top of it. And after that, for condition under sunlight, you are going to put below the arrow. And usually, the short form for sunlight, I use UV, capital letters. And next, I'm going to show what's the product's form. So we know this is free radical substitution reaction where one bromine atom from this Br2 molecule will replace one hydrogen from alkane. So I'm going to take out one hydrogen from here to replace with one Br atom. So what's left is going to be CH3Br plus with one hydrogen left will be combined with another Br atom from here. So it will be HBr as your side product. You can see from here, all hydrogen atoms in this alkane got the same class, which is primary hydrogen. So that's why I only got one possible major product. So this is what we call as major product. And HBr is what we call as side product. Or another name for it is byproduct. So settle for the first one. Next, we are going to continue with step 1, chain initiation step. At this step, we are going to do the homolytic cleavage between bromine molecule. So please open the bond between two bromine atoms. So how I'm going to do this, I'm going to draw Br bonded with Br. And the next one, I'm going to show the homolytic cleavage where my condition to produce the product, I need to have UV. So what's next? Homolytic cleavage happens when this bond splits symmetrically. So I'm going to use half-headed arrow. One of it go towards the bromine at the right and another one more to bromine at the left. And what's next? You will form two bromine radicals. How to draw that? You are going to put radical Br and another one more, same. So this is your answer. Or you can also write it down as two bromine radical. This is also acceptable. So this is for the step 1, chain initiation step. And the halogen molecule here that we use in this case is Br2. But if the question asks you methane with chlorine, so you can change your equation with Cl2 and this atom here also Cl2. I hope you're clear with step number 1. Next we go to step number 2, chain propagation step. Chain propagation step is the step continuing from the previous one. So at the product side, you got Br radical. So I'm going to take Br radical. I put it like this. Br dot. Reacts with another reactant that I don't use yet, which is CH4. So I'm going to open all the bonds in methane. So I got one hydrogen attached to carbon, the next hydrogen, next one, and next one. Why this bond I make it a bit longer? Because I'm going to show the reaction between this hydrogen and this bromine radical. So that's why when you draw your structure for alkane, please show a bit longer for the bond between carbon and hydrogen that you want to replace later on. So let's continue. What will happen? I'm going to show the mechanism by using 3 half-headed arrows. The first one is I'm going to show the bond cleavage between these atoms. So one of it will go to carbon and the second one will go to the middle and another one more from radical go to the middle. So from here, you will bring Br together with the radical, 1 electron, and you will bring 1 electron together with hydrogen to form HBr. And what's left, this 1 electron that goes to carbon will form methyl radical. So how I want to draw my product, I'm going to draw it just like this one. Plus, so this is my product for the first line of propagation. As you know from before, free radical is very reactive, so it cannot stay alone, so it must be bonded to another atom. So that's why I cannot leave it methyl radical here just as it is. I'm going to continue from this radical. I'm going to copy it. So I got CH3 with radical reacts with another reactant. So another reactant that I mentioned here, if you take a look at your equation, you got Br2 and CH4. Methyl radical is coming from CH4. So another reactant that I can use is Br2. And this Br2 is not the same one for this case. It means that another Br molecule in this reaction. So I'm going to open the bond between Br molecule. So this is how it looks like. It is the same with the propagation step from just now. I'm going to use 3 half-headed arrows. The first one is where the bond cleavage happened here. So I'm going to take 1 electron from this bond, go to bromine at the right. And the next one, 1 electron from here, go to the middle. And this radical go to the middle. So it means that CH3 radical will combine together with Br, and this bond splitted to form one Br radical. So my product will be like this one. So settle for propagation. And as I mentioned before, again and again, radical cannot stay as it is. So this Br radical will react with another CH4, and the reaction will be the same as above, and continuation from here again and again and again. So to make this propagation step to stop, we are going to proceed with the step number 3, where chain termination step. Chain termination step is when you will combine all free radicals which are the same and different together. So as you see from here, you got bromine radical and you got methyl radical. So we are going to start with 2 bromine radicals. So I got Br radical reacts with the same Br radicals. So what will happen here, we are going to combine both of them. From here go to the middle, from here go to the middle. It means that you are making a bond between 2 Br atoms. So your product will form Br bonded to Br, or you can write it down as Br2. Next one, you got methyl radical, either in this form where you show the bond between 3 hydrogen atoms, or you can make it in this form as well to save a space. So I'm going to use whichever that I'm comfortable with. So I'm going to take the simplest one. So I got the first methyl radical reacts with another same methyl radical. So what will happen here, I'm going to combine both of them together, 2 half-headed arrows. So my product is going to be CH3 bonded to CH3. So this is the bond forming from this combination. And last but not least, you need to show the bond formation between 2 different radicals in this reaction as well, which are methyl radical with bromine radical. So the reaction will happen between this bond formation. So I'm going to produce CH3Br. Make sure your Br atom is connected to carbon, not hydrogen, because you understand that we need to get this product by the end of the reaction, CH3Br. So as you see from here, your mechanism is correct. So this is how you want to show or describe the mechanism of free radical substitution. I hope all of you can understand this reaction where you form free radical through substitution reaction, where you replace one hydrogen atom from alkene with one halogen atom from halogen molecule. There are few key points that you need to understand. Alkene can only undergo free radical substitution reaction. And if I ask you the name of reaction, the name of it is halogenation because you use halogen. They can be either bromine molecule or chlorine molecule. And the next one, if I ask you about type of reaction, this is TOR and this is NOR. So the type of reaction is free radical substitution. And if the question asks you about the reagents used in this reaction, you can write it down as bromine in dichloromethane, or you can also write it in chemical formula form Br2 in CH2Cl2. This is also acceptable. And the next one, if the question asks you to list down the condition, you can write it down as under sunlight or capital letters UV. If you do the experiment for free radical substitution on alkene under sunlight, you can expect one observation from the experiment, which is reddish brown color of bromine solution turn colorless. Reddish brown color solution will look like this solution in this picture. And once it turns colorless, it will appear like this color, such as a colorless liquid. But if the reaction undergo in a dark condition, this expected observation cannot be observed because there is no sunlight for alkene. It means that there will be no homolytic cleavage happen in bromine molecule because there is no enough energy for this reaction. So in order for you to relate with the mechanism that you illustrate from the previous page, which is this one, it means that by the end of the step 3, if you got the correct illustration of mechanism, it means that the final color of the solution turn colorless from reddish brown solution. That's how you want to relate the theory with the real life experiment. I hope all of you can describe the mechanism of whichever alkenes being given in the question by using free radical substitution reaction. You can try to complete exercise 3 so that you can understand more about this last subtopic, chemical properties of alkenes. That's all for this video. Thanks for watching. I hope you can like, subscribe and share this video with people around you. That's all from me. I'll see you in the next one. Bye!